In this section, we will look at graphing sinusoidal functions. So now that we know how to identify different parts of a sinusoidal function, we can use that information to produce the graphs of the functions. Since we haven't talked about the variable h yet, these steps are only for graphing sinusoidal functions of the form y equals a times the sine or cosine of the quantity b times x plus k. Here are some steps to keep you organized. Step 1. Identify the amplitude and whether there is a horizontal reflection. The amplitude is equal to the absolute value of a. If that a value has a negative in front of it, then that's what tells you there's a horizontal reflection. Step 2. Identify the midline. The midline is the line y equals plus or minus k. If the k value is positive, then that's a horizontal shift up, and if the k value is negative, that's a horizontal shift down. Step 3. Identify the period and whether there's a vertical reflection. The period is equal to 2 pi divided by the absolute value of b. If the b value is negative, then that's what tells you there's a vertical reflection. Step 4. In order to graph, you'll want to divide the period into 4 equal lengths. Then, on a graph, you'll make a tick mark and label on the horizontal axis for each one of those 4 equal lengths. 4 of these equal lengths should equal 1 period of the function. Step 6. On a graph, determine the location of the midline, which is a horizontal line. You'll also want to make a tick mark on the vertical axis and label each one of those tick marks. Step 7. From the midline, you'll use the amplitude to identify the local maximum and minimum of the function. Step 8. You'll want to determine the parent function, and that'll be either y equals the sine of x or y equals the cosine of x, and what the graph of that function looks like. And finally, step 9, you'll sketch 1 period of that function. That 1 period, of course, can be repeated to create a more extensive graph if you like. Now let's take a look at some examples. Before we take a look at some examples, let's just go back to this idea of a parent function that I just mentioned. We've seen the graph of the sine function and we've seen the graph of the cosine function. But side by side, I just want to point out a couple of things. The graph of y equals the sine of x, let's just notice that that graph is always going through the origin. And we know that the graph goes up, and then it comes down, and then it comes up again. Notice a couple of things. Not only do we cross the x-axis at the origin, but we also cross it halfway through at pi, and then at the end of the period at 2 pi. In between 0 and pi, we are hitting our maximum value, and we're hitting our minimum value between pi and 2 pi. Now, cosine has the same shape, but it's a little bit different. At 0, we are at the highest value. We are at the maximum value of 0, 1. We don't see ourselves up at that maximum again until the end of the period, which is at 2 pi. Halfway between, at pi, we're at the lowest value. And between 0 and pi, at pi over 2, we're at the midline. And we're at the midline again at 3 pi over 2. Going back to that sine function, I said that we started at the origin. What we're actually starting at, though, is the midline. In this particular example, that midline is the origin. But when that midline changes, you'll want to keep that in mind. So the examples that we'll look at will be for you to graph the function -3 times the sine of quantity x plus 2, graph g of x equals 4 times the cosine of the quantity pi over 2x, and graph h of x equals -1 plus 5 times the sine of the quantity 5 times x. Now, we've seen these equations already. We've identified a few things about them, but now we want to graph them. So let's do one at a time. f of x equals -3 times the sine of the quantity x plus 2. So in order to graph this, we're going to use our how-to list and identify some things, and then we'll walk through how we actually put this all together to form the graph. Number 1 is to identify the amplitude and whether or not there's a horizontal reflection. So let's see here. The amplitude is going to equal the absolute value of this number on the outside of the function. So the absolute value of -3, which is 3. Now, because that negative is there, it doesn't affect the amplitude, but what it does affect is the fact that there will be a horizontal reflection. So we want to remember that. And that's why we're writing it down. All right, next step, identify the midline. The midline we're going to write as the equation of a line, and that's going to be y equals whatever this number is on the outside of the function, also being added or subtracted. In this case, that's a 2, so my midline is going to be y equals 2. Next step, identify the period. The period is equal to 2 pi over the absolute value of my b value. Now my b value in this case is the number inside the argument with the x, which is 1. So 2 pi divided by 1 is simply 2 pi. There is no negative sign inside that argument, and so that's what tells me there is no vertical reflection. The next step is to divide that period into 4 equal lengths. 4 equal lengths. So I'm going to take 2 pi and I'm going to divide it by 4. That gets me 2 pi over 4, which reduces to pi over 2. Now, on a graph, I'm going to make a tick mark on the horizontal axis for each of these 4 equal lengths. So, starting at the origin and moving to the right, my first tick mark is 1 pi over 2. My second one is 2 pi over 2, which reduces to pi. My third one is 3 pi over 2. And the last one is 4 pi over 2, which reduces to 2 pi. Now, if I've done this correctly, then 4 of these equal lengths of pi over 2 should equal 1 complete period, and it does. We started at 0, we end at 2 pi, and that is the period of this function. Next step. On a graph, we want to determine the location of the midline, which is a horizontal line. All right, so my midline is at y equals 2. So I'm going to go ahead and mark this y-axis with some tick marks and label those. So there's y equals 2. Personally, I always like to draw maybe a sketched line through that y equals 2. And then from the midline, I'm going to use the amplitude to identify the local maximum and the minimum of the function. So my amplitude is 3, so up from 2, I'm going to go up 1, 2, and 3, so that puts me at 5. That's going to be the tallest that my graph is. It's not going to be any taller than that. And then from that midline, I'm going to go down 1, 2, and 3. So it puts me at -1, and that's the lowest that my graph will be. There it is. Okay. What's the next step? Determine the parent function. This is a sine function, and here's what we know about a sine function. If you recall from a couple slides ago, a sine function begins at its midline. So we're going to begin at our midline, which is at 0, 2. Now, it not only begins at the midline, but it ends at the midline, and halfway between, it's also at the midline. Now, normally it would go up from the starting, come down, and then go back up. But remember, we have a horizontal reflection. And so instead of going up, I'm going to go down. Halfway between 0 and pi is pi over 2. And down here at my most minimum point, I'm going to put a mark there. And that's going to go down. It's going to come up. And then there's really only one thing that it can do, which is to go up to that maximum value and complete one period of the function. Now, of course, if I wanted to continue this graph, I certainly could. I could label things to the left. I could label things more to the right. But this is an example of graphing one period of this function. Let's try another one. Graph g of x equals 4 times the cosine of the quantity pi over 2 times x. Okay, step 1. What is the amplitude? The amplitude is the absolute value of this number on the outside, which is a positive 4. And the fact that there's no negative tells me that there is no horizontal reflection. Next step, identify the midline. The midline, even if there's nothing written on the outside, which is the case here, is still something. It's going to be y equals 0. Next step, identify the period and whether there's a vertical reflection. The period is equal to 2 pi divided by the absolute value of the b value. Well, my b value is positive, so I can just use pi over 2. And instead of dividing by pi over 2, I will multiply by 2 over pi. So those cancel out, and I'm left with a period of 4 and no vertical reflection. Now I want to take that period and I would want to divide it into fourths. So I'm going to take 4 and I'm going to divide it by 4, and that tells me I'm going to have 4 equal lengths of length 1. And I'm going to mark those on the horizontal axis. So I'm going to have 1, I'm going to have 2, I'm going to have 3, I'm going to have 4, and maybe I'll just go ahead and show you if I want to extend that period. Okay. On the graph, I now want to determine the location of the midline, which is that horizontal line. So my midline is going through y equals 0. If I want to do a sketched line here, I can, but it's going right through the x-axis. And then the amplitude is 4. So up from that midline is 1, 2, 3, and 4. I want to label that. And 4 is going to be the highest value that I'm going to see. And then I'm going to go down. And -4 will be my lowest value. And of course, I want to mark that vertical axis as well. Okay. The next step is to determine the parent function. Well, we have a cosine function, and so we have to think back, what are the characteristics of a cosine function? A cosine function at 0 hits its highest value. Now, if there was a horizontal reflection, then instead of hitting my highest value, I'd be hitting my lowest value. But this one doesn't have that, so I'm going to go ahead and put a mark at the highest value at 0, 4. Now, it repeats itself, doesn't repeat itself until the end of the period, which is at 4, 4. And because I know that's the highest value, I sometimes like to just put a little curve there to remind myself. Halfway between, at 2, it's going to hit its lowest value. It's going to be something like that. And then in between, it hits its midline. And if I connect these values, I see one period of this function g of x. Now I put the arrow on there to indicate that it keeps on going, but I could also, if I wanted to, on the left-hand side, I could do one more period, just so you see what it looks like. And there's a second period of this function. Let's try another one. So let's try this last one. H of x equals -1 plus 5 times the sine of the quantity 5 times x. And we've answered these initial questions already, but let's just do it again for practice. The amplitude is the absolute value of this number that is connected by multiplication to the sine or cosine function. This number a is already positive. The absolute value of positive 5 is simply 5, and because that 5 is a positive number, there is no horizontal reflection. Second step is to identify the midline. The midline is always written as the equation of a line, so it's y equals whatever this number that is added or subtracted to the function is. Well, in this case, we are adding a -1, so we're going to say that the midline is y equals -1. The period is equal to 2 pi divided by the b value. Now, the b value is the number that's on the inside of the argument. That number is positive, so we don't have to worry about a vertical reflection. And then the other thing we don't have to worry about is 2 pi over 5 does not reduce. So that is our period. Now, next step is we want to divide that period into 4 equal lengths. So that period of 2 pi over 5 divided by 4 is the same thing as 2 pi over 5 times 1/4. Now that will reduce. That's going to give me 2 pi over 20, which is pi over 10. Now, recall that what that means is that I'm going to make a tick mark on the horizontal axis for each of those 4 equal lengths, and that 4 of those equal lengths should equal 1 period. Let's see if it does. So starting at the origin, 1 tick mark to the right, that is going to be 1 pi over 10. The second tick mark is going to be 2 pi over 10, which reduces to pi over 5. The third one is going to be 3 pi over 10, doesn't reduce. And finally, the last one will be 4 pi over 10, which reduces to 2 pi over 5. And that's good news because that's what my period is. Okay, so now we've got it all set up. The next step is to determine the location of the midline, which is the horizontal line. The midline is at y equals -1. Now this is going to be a little tight here because I made my fractions a little bit large, but starting at the origin and going down to -1, that is going to be, maybe I'll do it in a different color. My midline is going to be going through -1. There it is. Okay, now from that midline, I'm going to now go up 5 and I'm going to go down 5. So going up 5, I'm going to go up 1, 2, 3, 4, 5, and that puts me at a value of 4, right? Because this was 0, then 1, then 2, then 3. So 4 is going to be my largest y value. And then if I go down 5, so -2, -3, -4, -5, -6. I think I got that in there. 1, 2, 3, 4, 5. I did. Okay, so my lowest value will be -6 for a y value. All right, next step, determine the parent function. This is a sine function, and what we know about sine functions is that starting at 0, they go through their midline. So my midline is at -1. So that's going to be my first value. And I'm going to see that value again at the end of the period. And I'm going to also see that value halfway between. Now, starting at 0, -1, normally it's going to go up and then come down and then go back up. And that is the case here because we don't have a horizontal reflection. Last time we did. So halfway between the 0, -1 value and the pi over 5, -1 value, we will put a point at pi over 10, 4, because we want to see that largest value. So it's going to go up and it's going to come down, and then halfway between pi over 5 and 2 pi over 5 at 3 pi over 10, it's going to hit its lowest value. And there we go. And what's really nice about dividing the graph into fours is that if I want to graph more of this period, let's say I'm at 0, -1. If I just go to the left, 1, 2, 3, 4, I can put my pen down. If I'm at pi over 10, 4, I can just go to the left, 1, 2, 3, 4, and put my pen down, and there's another point. I'm going to do the same thing for pi over 5, -1, 1, 2, 3, 4. It's going to come down. I'll do the same thing for 3 pi over 10, -6. I'll go to the left, 1, 2, 3, 4. And then finally, I'll connect back to 0, -1. Now, why am I moving to the left 4? Because I divided the period into fourths, so I know that every 1/4 of the period, I'm seeing some of those key values. And why am I dividing by 4? Well, it all comes from the unit circle, right? And how many quadrants are in a unit circle? There are 4. So what we're really graphing here is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And that's what gives us a sketch of these sinusoidal functions. So let's look at an application of sinusoidal functions. The population of a city has risen and fallen over a 20-year interval. Its population may be modeled by the following function. The function is y equals 12,000 plus 8,000 times the sine of the quantity 0.628x, where the domain is the years since 1980 and the range is the population of the city. After how many years does the population trend begin to repeat? Okay, so what you have to do in order to answer this question is think to yourself, which of the things that we've talked about have to do with repeating? We've talked about amplitudes, which would give you maybe your highest population or your lowest population, your midline, which would be maybe the average or the middle population. And then we've talked about the period, and the period is when we see the function begin to repeat. So the word repeat goes along with this question, doesn't it? After how many years does the population trend begin to repeat? So what I think is that if I can identify the period of this equation, then I'll have the answer to my question. So what is the period of this function? The period of this function is equal to 2 pi divided by my b value, which is 0.628. Now, I am going to need a calculator for this one. And when I put that into my calculator, I got 10.005, and there were some more digits after that, but I'll just stop there. And I think that I will say after how many years, so this 10.005 represents the years that the population will begin to repeat. So one thing you always want to do with a word problem is you want to answer it with a complete sentence. So I will say after approximately 10 years, they don't tell me if I should round or not, but I'm going to just say approximately 10 years, the population will begin to repeat. So if we started with the year since 1980, then we could expect to see 1990 it repeats, the year 2000, 2010, 2020, you get the idea, 2020. So that's the way I would write that. The last example that we'll look at in this section is to do the opposite of what we've been doing. What we've been doing is I gave you a sine or cosine function, you graphed it. Now you have the graph and you're being asked to write a sine or cosine function to model the graph. So it's sort of like we're working in reverse. If you remember those how-to statements, instead of going 1 through 9, if we go 9 through 1, I think we'll have a little bit of a feel of what this function can be written as. So one of the last things that we did was to determine the parent function, whether or not it looked like a sine function or a cosine function. What do you think that this looks like? What I usually do is I start at 0. I start at 0 and I look to see where is the output at 0. I know that if I'm at my highest point, then that's a cosine function. If I'm at my midline, then that's a sine function. In this particular case, it looks like I'm not at my highest value, but I'm at my lowest value. So what that tells me is that this is a cosine function. This is a cosine function that has gone through a horizontal reflection. It's gone through a horizontal reflection. So what that means is that my A value is going to be a negative number. All right, what else do we know here? Let's talk about the midline, all right? We can see that the largest value is at 5 and the smallest value is at 1. Now, I haven't given this before, but let's go ahead and do it now. If we're working backwards like this, we can say that the midline is equal to the maximum value plus the minimum value divided by 2. Now, I don't know that you need another formula to memorize, because I think, you know, if you were to just sketch in that jagged line at 5 and sketch in a jagged line at the lowest value at 1, I think that you can see that between 1 and 5, that middle value is at 3, right? That middle value is at 3. So I think that you can see that the midline is at y equals 3. But let's see if this would have worked. The maximum is at 5. The minimum is at 1. 5 plus 1 is 6. And 6 divided by 2, sure enough, is 3. So we're going to call this y equals 3, and that works. What is the amplitude? Well, the amplitude is the distance from the midline to that maximum value and to the minimum value. And we can see from that midline of 3 that we go up 2 and we go down 2. So we're going to say that the amplitude is at 2. So what is this function? Let's call it f of x. And the first thing we write in f of x is that a value, which I said was an amplitude of 2, but we also identified that there was going to be a horizontal reflection. So I'm going to say negative 2, and we said it was a cosine function. And let's see, I guess we didn't say what the b value is, and the b value, remember, comes from the period. What is the period of this function? Well, at 0, we were at 1, and we don't see that repeat until right here at 5. So the period, let me just see if I can squeeze this in. The period is equal to 5. Now, is that the number that I put inside of the equation of the function? The answer to that is no, because the number that's going to go inside the argument of this cosine function is actually where the period is equal to 2 pi over b, and it's that b value that we want. Now, I'll leave the solving of b to you, but what you should find out after you do that is that my b value is 2 pi over 5. And then I'm going to hook an x on. And then my last step is going to be to write the midline. And I said that the midline was positive 3, so I'm going to write plus 3. And I believe that the function negative 2 times the cosine of the quantity 2 pi over 5x plus 3 if I were to put that into Desmos or put that into a graphing device, that I would get the picture of the graph that we see modeled on this slide. And you should try it. You should give that a try and see if it works. I think it will.